On March 23rd, 1989, not 1999, the Apollo group Asteroid 4581 Asclepius 1989 FC passed within roughly 425,000 miles to 450,000 miles of Earth. A significant near miss, the 0.244-0.3 kilometers wide asteroid was only discovered after it has passed, passing through the position Earth occupied just 9 days prior. So this event spurred increased ENO tracking. Key details of 4581 Astronomers and the near miss date. The close approach occurred on August 23rd, 1989, not 1999. Discovery. The asteroid was discovered on March 31st, 1989 by Henry Holt and Norman Thomas at the Palomar Observatory days after its closest approach. Distance missed the Earth's approximately 425,000 miles, 425,000 to 450,000 miles, approximately 0.0046 AU size and impact potential, with a diameter of roughly 300 meters, and that's about 1,000 feet. A collision would have released energy equivalent to a 600 megaton bomb. Significance. March 23rd is sometimes referred to as National Near Miss Day to mark the event and highlight the importance of asteroid detection. And so once again, I'd like to welcome you guys back to another episode of Astral Adventure. And I'm your host, John Shav. And today in this video, we're going to be covering this significant event. Again, it's called the Near Miss Day. And that's the day when this asteroid again occurred or passed Earth, March 23rd, 1989. The thing about it, no one even knew or even knew there was a near miss till after this had passed Earth. And so with Earth rotating, traveling through space of the universe, the very spot or location where Earth was previous was at is where the asteroid hit, and then somehow it went back into reverse and changed course. And so this next video is going to be explaining all of that. So stay tuned for a very interesting and educational video on this miss. So once again, thank you for rocking with us and tuning in to each and every. We thank you in advance for watching. Back, relax, enjoy this video and this presentation. Don't forget to support us by liking,
Astral Adventure, the story of 4581
Again, your host,
Asclepius.
John Shav.
On March 23rd, 1989, humanity came closer to extinction than almost anyone realized at the time. A mountain-sized asteroid named 4581 Asclepius 1989 FC passed through the exact spot where Earth had been just 6 hours earlier. In this episode of Astral Adventure, we dive into the chilling details of this near miss. The power, why a collision would have equaled a 600 megaton atomic blast. the surprise. Why astronomers didn't even discover the asteroid until 9 days after it passed. The legacy. How this event gave birth to National Near Miss Day and revolutionized how we track near-Earth objects, NEOs. Are we prepared for the next one? Join us as we explore the cosmic scale of close calls. Subscribe to Astral Adventure for more space history and planetary defense updates. The story of 4581 Asclepius is often called the 6-hour close call because the asteroid passed through the exact point in space where Earth had been just 6 hours earlier. At the time of its closest approach on March 22nd to 23rd, 1989, it was roughly 425,000 to 450,000 miles away, about twice the distance to the moon. Why it was so dangerous. The power of impact. Geophysicists estimate that a collision would have released roughly 600 megatons of energy. For context, this is 12 times more powerful than the largest nuclear weapon ever detonated, the Tsar Bomba, an equivalent to roughly 20,000 hydrogen bombs. Catastrophic effects. An impact would have excavated a crater 5 to 10 miles wide and a mile deep, obliterating everything within a 40-mile radius. If it had hit the ocean, the most likely scenario, the resulting tsunamis would have been large enough to engulf entire coastal cities. The invisible threat. The most chilling part of the story is that humanity was completely unaware of the danger as it happened. Late discovery. The asteroid was discovered on March 31st, 1989, 9 days after it had already passed Earth. Technological limits. In 1989, computerized sky surveys didn't exist yet. Astronomers Henry Holt and Norman Thomas only found it while reviewing photographic plates at the Palomar Observatory over a week later. The wake-up call. This near miss changed how the world views space threats. It led to National Near Miss Day, celebrated every March 23rd to acknowledge our second chance in the unpredictability of space. Planetary defense. The realization that city killer objects could go unnoticed spurred the development of modern detection programs like NASA's Near-Earth Object Observations Program. Future monitoring. Scientists now track Asclepius closely. It is scheduled for another notable but safe pass on March 24th, 2051. To put 4581 Asclepius in perspective, it is significantly larger than the buildings we consider skyscrapers. With an estimated diameter of about 500 meters, 1,640 feet, it would tower over most major landmarks. Size comparison table. Object dot per mound. Height dot diameter. Compare 20 meters. Chelyabinsk meteor to 25 dies larger. Empire State Building, 3 Empire meters, is about 30% taller and wider. 4581 Asclepius to Eiffel Tower, 330 meters, is roughly 1.5 times taller. Burj Khalifa, 828 meters. The tallest building is about 1.6 times taller. Asteroid Bennu, 492 meters, an identical twin in size. Chicxulub Dino Killer, 20 times larger, a global extinction event. Visualizing the impact. If Asclepius were placed in the middle of a major city, its footprint would cover several city blocks. Because it was traveling at roughly 45,000 miles per hour during its 1989 pass, its kinetic energy was the real threat. While the 20-meter Chelyabinsk meteor shattered windows and injured 1,500 people in 2013, Asclepius is large enough that it wouldn't just burn up or explode in the atmosphere. It would maintain its integrity and slam into the surface with the force of a continental scale disaster. In the decades since the 1989 near miss, NASA and international partners have moved from simply cataloging asteroids to actively testing ways to stop them. Planetary defense is now a coordinated global effort led by NASA's Planetary Defense Coordination Office, PDCO. 1. Active deflection, the DART mission. In September 2022, NASA proved it could physically nudge an asteroid off course. The Double Asteroid Redirection Test, DART, spacecraft intentionally crashed into the moonlit Dimorphos at 14,000 miles per hour. Result: the impact shortened Dimorphos's orbital period by 32 minutes, far exceeding the goal of 73 seconds. Significance: this validated the kinetic impactor technique, confirming that slamming a spacecraft into a hazardous rock can effectively change its trajectory. 2. Advanced detection, NEO surveyor. To prevent another surprise like Asclepius, NASA is building the NEO surveyor, a dedicated space telescope scheduled to launch as early as September 2027. Infrared hunting. Unlike ground-based telescopes, it uses infrared to find dark asteroids that reflect very little light. Goal: it aims to find 90% of all near-Earth objects larger than 140 meters, the size of a small stadium, within 10 years of its launch. Strategic location: it will sit at the L1 Lagrange point between the Sun and Earth, allowing it to spot asteroids hidden by the Sun's glare. 3. Constant monitoring. Sentry 2. Since 2021, NASA has used an advanced algorithm called Sentry-2 to monitor impact risk. Yarkovsky effect. Unlike the original Sentry system, Sentry-2 can calculate how an asteroid's path is subtly shifted by thermal radiation, sunlight heating its surface, which is critical for long-term tracking over decades. Precision. It continually scans the CNEOS database for any known asteroid that might hit Earth within the next 100 years. 4. Global networks. Planetary defense now relies on a worldwide web of surveys, including Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona. These systems now detect roughly 3,000 new near-Earth asteroids every year, ensuring that invisible threats are becoming increasingly rare. As of April 2026, NASA's Sentry-2 system continues to monitor thousands of objects. While no known asteroid has a high Torino scale rating, all are currently at 0, meaning no significant danger. There are a few specific objects that scientists track with particular focus due to their size or potential future proximity. Highest Priority Watch List 2026 Update. 1950 DA 29075, the long-term threat. This is a massive 1.3 kilometer wide asteroid. For years, it held the highest risk score on the Palermo scale. The date. Its potential impact date isn't until March 16th, 2880. Current risk. Recent updates from JPL's CNEOS have downgraded its impact probability to roughly 1 in 30,000. While low, its sheer size makes it a permanent fixture on the watch list. Bennu 101955, the most dangerous. Near term, Bennu is approximately 500 meters wide, roughly the same size as 4581 Asclepius. The date. Scientists are watching a window in the late 2100s, specifically the year 2182. Current risk. There is a cumulative 1 in 2700 0.037% chance of impact between now and the year 2300. Because NASA's OSIRIS-REx mission successfully returned samples from it, we now have the most precise orbital data for Bennu of any asteroid in the solar system. 2024 YR4, the high probability small object. This asteroid gained attention in early 2025 and 2026 for having one of the highest impact probabilities ever recorded for an object its size, approximately 50 to 60 meters. The date. A potential encounter is predicted for December 22nd, 2032. Current risk, while its probability has fluctuated between 1.5% and 3%, its relatively small size means it would likely be a city killer or airburst event rather than a global catastrophe. 99942 Apophis, the safe legend. Once a level 4 on the Torino scale, it is now confirmed to have zero chance of impact for at least the next 100 years. The event, it remains on everyone's radar because of its record-breaking close approach on April 13th, 2029, when it will pass closer to Earth than our own communication satellites and be visible to the naked eye. Recent close approaches, March-April 2026. In just the last few weeks, several smaller asteroids have passed closer than the Moon. 2026 GD, a house-sized asteroid that safely passed within 156,000 miles on April 9th, 2026. 2026 EG1, a bus-sized object that flew by at 198,000 miles in January 2026. You can track asteroid flybys yourself using several official and interactive tools that provide real-time data on everything orbiting near our planet. 1. NASA's Eyes on Asteroids. The Eyes on Asteroids web app is the most user-friendly way to see what is happening in our cosmic neighborhood. Real-time visualization. View a 3D model of the solar system with every known near-Earth object, NEO, updated daily. Asteroid Watch, a specific tab that shows the next 5 closest approaches to Earth with a live countdown for each. Time travel. Use the slider at the bottom to scroll forward or backward in time to see exactly how close an object like Apophis will get in 2029. 2. Asteroid Watch Dashboard. If you want a quick summary without the 3D graphics, the NASA JPL Asteroid Watch Dashboard is the weather report for space rocks. Key stats. It lists the next 5 flybys within 4.6 million miles, 7.5 million kilometers. Size comparison. It uses relatable icons like a bus, car, or house to help you understand the size of the passing object. NASA Jet Propulsion Laboratory, JPL.gov. 3. CNEOS Close Approach Tables. For those who want raw scientific data, the Center for Near-Earth Object Studies, CNEOS, provides the definitive data tables. Customizable data. You can filter by date, velocity, and distance measured in lunar distances or astronomical units. Century risk table. You can also check the Century Impact monitoring page to see a list of objects being analyzed for long-term potential impact risk. 4. Third-party trackers. The Sky Live. Use the Near-Earth Objects Tracker to see a list of interesting objects currently visible or approaching. ESA Asteroid Toolkit. The European Space Agency provides its own close approach list and a flyby visualization tool that shows how an asteroid's path bends as it passes Earth's gravity. You can start by checking the 5 asteroids passing Earth closest to right now, April 16th, 2026. While 4581 Asclepius won't be back for a major flyby until March 24, 2051. There are several others on today's radar. Live flyby schedule, April 16th through 17th, 2026. According to the European Space Agency's close approach list, these are the objects making their closest pass in the next 24 hours. European Space Agency 2026 GT, passing at 12:56 UTC today. It is currently one of the closest tracked objects for this window. 2026 GA2, following closely at 13:13 UTC today. 2015 VX2, a returning object that peaked earlier this morning at 10:16 UTC. 2026 GA1, scheduled for its closest pass early tomorrow, April 17th at 3:57 UTC. How to see them right now. Open the 3D map. Go to NASA's Eyes on Asteroids. Search for today's objects. Type 2026 GT into the search bar at the top right. Visualizing 4581 Asclepius, search for Asclepius to see its current position in its 1.03 year orbit around the Sun. You'll see that it is currently far from Earth, heading toward its next close approach in 2051. Use the Asteroid Watch tab on the left-hand menu of the app. Click Asteroid Watch to see a scrolling ticker of the next 5 closest approaches with live distance countdowns. Planetary defense check. Notice that while many objects like 2026 GD, which pass within 156,000 miles on April 9th, are categorized as close, they are safely monitored. Modern tracking is now so precise that we frequently spot car-sized or house-sized asteroids just days before they arrive, a major improvement over the 9-day delay we saw with Asclepius in 1989. Tracking 99942 Apophis provides a glimpse into one of the most significant celestial events of our lifetime. On April 13, 2029, this 340-meter asteroid, roughly the height of the Eiffel Tower, will pass just 19,000 miles, 31,000 kilometers from Earth's surface. NASA science. This distance is closer than the geostationary satellites that provide our TV and weather data. NASA science.gov. How to track the 2029 path. You can visualize the trajectory using these steps in NASA's Eyes on Asteroids. Search Apophis. Locate the asteroid in its current orbit. Jump to April 13th, 2029. Use the date tool to see it dip inside the ring of geostationary satellites. Observe the bend. Watch how Earth's gravity significantly alters its path, reclassifying it from an Aten-class asteroid orbiting mostly inside Earth's path to an Apollo-class asteroid orbiting mostly outside. European Space Agency, where to watch it live. For the first time in recorded history, an asteroid of this size will be visible to the naked eye. Peak visibility, Friday, April 13th, 2029 at approximately 2146 UTC. Best locations. Residents in Africa, Europe, and Western Asia will have the best view as it streaks across the sky like a fast-moving star. What to expect? It will appear as a point of light moving roughly the width of a full moon every minute. Scientific missions joining the flyby. Because this approach is so rare, happening once every few thousand years for an object this size, several spacecraft are already preparing to meet it. OSIRIS-APEX, NASA, formerly OSIRIS-REx, this craft is currently en route to rendezvous with Apophis shortly after its closest approach to study how Earth's gravity physically changes the asteroid's surface. Ramses, ESA, a proposed mission to accompany Apophis during the flyby to observe asteroid quakes triggered by Earth's tidal forces. When Apophis passes within 20,000 miles of Earth on April 13, 2029, it will essentially undergo a planetary massage from Earth's gravity. Because Apophis is a rubble pile, a loose collection of rocks held together by very weak internal gravity. Earth's tidal forces will pull on its near side more strongly than its far side. What happens during an astroquake? Scientists from Johns Hopkins Applied Physics Laboratory and other institutions have simulated this encounter and expect two major physical changes. Seismic shaking. Around an hour before its closest approach, the asteroid will begin to experience tremors. These quakes will likely cause boulders to tumble and surface dust to shift. Surface refreshing. This seismic activity will reveal fresh material from beneath the surface. Over thousands of years, sunlight and radiation weather the outside of an asteroid, turning it redder. These quakes will likely flip or bury old rocks, exposing neutral colored material and changing the asteroid's overall appearance. Orbital and spin changes. Earth's gravity will torque the asteroid, potentially shortening its 30.6-hour day or causing it to start tumbling in a new non-principal axis rotation. NASA Science.gov. How we will measure them. We won't just be watching from afar. We're sending seismometers to space. ESA's Ramses mission. The European Space Agency plans to deploy the Seismic Instrument for Asteroids, SIA. If a CubeSat from the mission successfully lands on Apophis, this instrument will perform the first ever in situ seismic study of an asteroid, recording the quakes as they happen. NASA's OSIRIS-APEX. After the flyby, OSIRIS-APEX will orbit Apophis for 18 months. It will use its thrusters to stir the surface, blowing away the top layer to see how much the internal structure was loosened by the Earth encounter. Harvard University. Why it matters. Understanding how a rubble pile reacts to gravity is critical for planetary defense. If we ever need to nudge a similar asteroid away from Earth, we need to know if it will stay in one piece or if it's so loose that our nudge might just poke a hole through it.